Okay, we're back with the third video now. We're going to start looking at question 8. And of course here they're showing you a table. But in this case here, since they're providing you with the line of best fit, or what they call the regression line in the book, and sometimes you may hear me use different vocabulary because I've used multiple books for statistics. But the regression line here, or the equation of it, is going to be y is equal to 0.449x minus 30.27. And it's asking to determine the residual. So first, how do you determine a residual? Okay, and this is in the book. I know it's going to be in, I think, section 4.2 if I'm not mistaken. But the residual is determined by the obtained value. So it's the value we obtain minus the value that we predict. So the reason they're giving you this table is they want to see is, can you identify the value that was obtained? Okay, so in this case here, because we are letting x equal to 98 and y equals 15, we have this value here, and they're seeing if we can use this equation properly to come up with a value that we predict. Because remember, we use this equation to determine what would be the predicted value based on the line of best fit calculated. So I'm going to write that over here. Y hat is equal to 0.449x minus 30.27. And I'm going to go ahead, I'm going to put the value of x of 98 into this. So it's going to be 0.449 times 98 minus 30.27. And if we round that to 3 decimal places, we're going to get a value calculated to 13.732. So this is what our prediction, this is what we predict based on the line of best fit that the calculator calculated for us, or in this case what was given to us. So what we obtain from the data is going to be 15. What we predict using the line of best fit is going to be 13.732. If we take the difference of that, we'll find that's going to be equal to 1.268, which is going to correspond, in this case, to choice D. Again, that's going to be in section 4.2 of the book. Hopefully, as a concept, it's not too bad. You just got to be sure you keep straight the difference between what is obtained, which is going to be from the table, and then what's predicted, which is going to be from the formula based on the given x value. Okay, halfway through the multiple choice section here now. Going to question 9. Okay. It says use the linear correlation coefficients to determine the coefficient of determination. And fortunately for this one, this is not a terribly difficult calculation. There's one little thing you got to remember. So if r is equal to, let me come up with a different sheet of paper here. If r is equal to negative 0.71, well, r squared is going to be equal to negative 0.71 in parentheses squared, and then that's going to yield the value of r squared. Now, notice here they use the capital R squared, but you'll find in the calculator it's going to be a lowercase r. It's a notation issue. And then for question 8 then, you'll find, hold on, that if you square that, you're going to get an approximate value of 50.5041, or if you make that into a percent, that's going to be 50.41%. And that's going to correspond to choice B in this case. So all you're doing is you're just squaring the correlation coefficient to come up with the coefficient of determination. That's it. Let's take a look at question 10. And again, this is just an analysis question. If you're looking for notes on how to do this, look in your book on pages 214 to 217. For more information on this, since I don't want to go and reteach this whole concept here, since it's just a practice test. So what they're asking is, does it violate any of the conditions for an adequate linear model? And what we're looking for is whether these dots form a pattern or they don't form a pattern. And if they don't, so if the plot of residuals show a discernible pattern, then the explanatory and response variables may not be related. But here these are random. So they do not violate any of the conditions for an adequate linear remodel. So that would be the correct choice for B. So what you want to look for is if you see something that forms a line and there appears to be some type of relationship, then it will not be an adequate linear model. Now, if what I'm saying makes absolutely no sense, please turn to pages 214 to 217 in your book. Let's go ahead and take a look now at question 11. This in your book is going to be pages 218 to 219. And what it's asking is if you have some type of a data point which is way off from the rest of them, it wants to know is point A, that point that's like far away, is it influential? And the way you tell whether it's influential is there is a significant change. Okay, so if this is influential, there has to be a significant change. And the correlation coefficient, which in this case there would be, or in the slope, or in the y-intercept. Now, I wish I could tell you that the book gives like some clear guidelines or parameters, like something numerically to do this. The book doesn't necessarily provide that. I'm not sure if your videos have provided that in detail or not. But if it causes a big change in this, like it goes from 1 to 3, which is almost tripling it, that's a pretty big change. It's dragging this line down significantly also. This is certainly bigger than the change than what you're going to see on the test. If the change is not very much, like if the line looks pretty close to what was originally there, after you put this additional point in, then you would say probably not. So, just take a look at what's on the test, and I would say use your best judgment about that. Read the book on page 218 and 219. I think you'll find that helpful. Question 12. In question 12, we're finally going into the later part of the book. This is information on question 12. It's going to be between pages 583 to 585. And it wants to know here, many track hurdlers believe that they have a better chance of winning if they start on the inside lane that is closest to the field. For the data below, the lanes closest to the field is lane 1. Start this again. The lane closest to the field is lane 1. The next lane is lane 2, and so on. They number from the inside outwards. Okay. Find the critical value to test the claim that the probabilities of winning are the same in the different positions. Use alpha equal to 0.05. The results are based on 240 wins here. Okay, so what we want to do is we want to find this critical value. So a few things we need to know. Our K value in this is going to be equal to 6 because we have 6 categories. Therefore, that means that our degrees of freedom, that's going to be equal to 6 minus 1, which is going to equal 5. So if we're going to find the critical value from the table, we need to know we have 5 degrees of freedom, and we have this value of 0.05. You see, you get the book on this. We have a table of values we need to utilize. And you will have this available for you on your next test here. So we have 5 degrees of freedom on the table, and we're going to go to 0.05. So this is going to be 11.070 from the table, and that's the value we have, choice B, for that question there. So there we're being asked to find a critical value. That's the value we're going to be finding from the table. Question 12, the information for question 13. That information is going to be available on pages 585 to 587 if you want to read up more on this. Okay, so this one's going to get a little complicated, but not too difficult to handle. I will be using a separate sheet of paper to illustrate the work on this, though. Show that better. Let's see here. Here we go. So first off, we need to look at, for this, is we're given 5 different categories. It's asking us to find the p-value to determine if the grade distributions for the departments is different than expected. And it says use a level of significance of Okay, so first let's go ahead and let's find a, let's put this together. Okay, so first off, for this one, we're going to have oh, just looking at this question here again. Oh, if it wants us to find the p-value, actually for this one, if we're just being asked to find the p-value, we can use technology for this. Okay, I was actually going to approach it with the classical method, but you know, let's just find the p-value for this. So if we're finding the p-value for this, we can do this with technology. Okay, what's going to go into, so you'll find the notes for how to do this with the graphing calculator between 585 to 587. What we're going to do in list 1 of the calculator, so we have a few things to do here. In list 1 of the calculator, make sure I'm showing all this question through. In list 1 are going to be the values from the numbers on the table, which would be in this case 42, 36, 60, 14, and 8. In list 2 is a bit of a different calculations. So this is what we actually obtained. These are what we call the expected values. So given that if we take all these and add these together, the total will be 160. So these are the values we actually obtained, but we're going to develop these expected values by multiplying all the percentages by 150. So like 42 are the actual number of A's, but if we expect 25% of students to get A's, we would take 160 times 0.25. If we have 160 students and 25% of them get B's, we would expect 160 times 0.25 of them to get B's. And you'll see the calculator will calculate this for you when you put it in the list. Again, we're going to work with 160 in each of these cases. But we're going to multiply the 160 each time by the percentage in each of these categories. So this would be 0.4. This is going to be 0.05. This is going to be 0.05. Watch how as I enter this into the list of the calculator here. Let's go up here and clear the list out. Oops. Try that again. Okay. So I'm going to enter this into here. 42, 36, 60, 14, 8. And then here I'm going to have, watch how I do this now. I'm going to take the total from here and multiply it by the percentage of what we expect the expected value to be. That'll be 160 times 0.25. Enter. It gives me the value. 40, should be, hold on. Try that again. 160 times 0.25. Let's try that again. Some reason it's not giving me what I'm expecting. 60 times 0.25. 40. Okay, that's better. Okay, here 160 times 0.25. And if you happen to see it's 40 from above, you could do that. 160, whoops, times 0.6. That, hold on. Yep, 96, that looks right. And then we'll have 160 times 0.05. Now, since we're going to be doing that the same calculation here, I can just go ahead and put 8 in. And now we've got our table put together. So the calculator does a nice job in calculating this p-value. We're going now to stat. We're going to go to test. And for this one, we're going to go to choice D for the test, which is going to be, oops, does this one not have it? Let's see, I think it may be under a different name because this is the TI-83. No, this one doesn't have it, guys. I'm going to try to use my other calculator to do this. Yeah, the difference is that one's an 83, this one's an 84. So I'll just have to type this in quickly. So I'll type at least type in the other information for the calculator here quickly. So this will be 42, 36, 60, 14, and 8. This will be 40, 40, 96, 8, 8. Okay, now if I go to stat and I go to tests, all right, I'm going to go to choice D, which is going to be the chi-squared goodness of fit test. That's what I want to use for that there. So I hit enter for that. And the observed is L1, the expected is L2, the degrees of freedom is 5. You just want to hit calculate and have it calculate the p-value. And you notice that the p-value is going to be 0.002. Okay, so when you calculate the p-value of 0.002 for that, hold on, let me see. Well, guys, I'm just looking at my table again because the results I got for this here did not come up. Hold on. 42, 36, 60, 14, 8, 40. Six, 8, and 8. Oh, hold on. I think 96 is too high for this. Yeah, it's going to be high for that. Let me try 160 times 0.6. Yeah, that's better. Let's try this again now. Stat. Yeah, technology is great until let's hit calculate now. Oh. All right, guys, I'm going to pause the video and try to correct this. One moment.